Welcome to this seminar hosted by the Swedish forest industries, in which we will dig a bit deeper into the climate benefits of the Swedish forest industries. I'm Viveka Beckerman, and I'm the Director General of the Federation. The current Commission's ambition is to make Europe the first climate neutral continent. This is an ambition that we applaud and want to contribute to. The debate is currently intense when it comes to forestry, climate and biodiversity. And we want this debate and this discussion to be based on facts. We have therefore asked Dr. Peter Holmgren, with a background with the FAO, to do a report on the climate benefits of the Swedish forest industry. We have also asked Professor Gert-Jan Boers to comment on the presentation that Peter will make. At the end of this hour, you will also be allowed to pose questions to the presenters. And in order to do so, I ask you to log into menti.com and enter the code that you see on the screen. But without further ado, I hand over to Peter. Welcome.
Thank you, Viveka. It's a great pleasure to have this opportunity to speak about forests, forestry, forest industries, and the climate benefits that we get from these activities. The report that we're going to present today is called Time to Dispel the Forest Carbon Debt Illusion. And the reason for this title is that it's often pronounced in the debate that if we harvest trees from the forest, it will take time before we can count any climate benefits from the forest management and the products. We would like to shed some lights on how this actually works in the Swedish case. Next, please. We've seen the debate over the past 6 months in particular, but also since long before that. In January this year, we had a film issued. It was in English, so some of you may have seen it. It argues that forest management is bad for the climate. We've earlier seen Chatham House report on bioenergy arguing that it will take time if we harvest for bioenergy to get the overall climate benefits that we want. Swedish daily newspapers have published several articles on the time delay of these climate benefits over the past months. And the environmental organizations, particularly in the EU, at the EU level, have argued the same things on various occasions. The Joint Research Center, the EU research body, issued a report some time ago about the forest bioenergy situation. And it's a good report. It makes a good review of all the aspects that needs to be considered. But they also make calculations that it will take time before the climate benefits accrue. That's the situation in the debate. And this is now to give another perspective on this. Next, please. What we call the forest carbon debt is actually a simplification of a model that has been developed first to look at bioenergy projects, particularly in the tropics, where, for example, rainforests are being replaced by oil palms, and the bioenergy produced from those oil palms will take a long time to pay back the debt that incurs when you harvest and deforest the area in the first place. So this is the model that has been used also for the situation of managed forests. If you look at the blue line, this is what is assumed to happen if we don't harvest the forest. We will then see an increase in the biomass in the forest and therefore the carbon stock until it reaches some kind of equilibrium when the trees that are still growing are balanced by trees that are dying in the forest from various damages. The red line illustrates what is assumed to happen if we harvest the forest and thereby lowering the amount of carbon in the forest permanently, or at least for a long time. This assumption is not valid in Sweden. I can say that already now because we are constantly increasing the carbon stock in the forest. And then the purple line in the middle is supposed to show the time it takes before we reach a break-even point far to the right by the products that are coming from the forest as they substitute fossil-based alternatives. So this is the model, and it has been applied in science in a number of cases. We went through the literature, and what we find in the literature is that although this science is well done and properly published, it has used narrow system boundaries and some fairly simplistic assumptions. Very often they look mainly at the bioenergy output from the forest. This is not the case in the Swedish situation, where bioenergy is the byproduct of other more valuable and actually more climate beneficial products. Many studies have looked at long-term projections without really taking into account real-world data. And this is problematic because long-term projections are very likely to be poor in precision. And finally, most studies have also not looked at externalities to the model. What happens in a scenario where we don't harvest the forest with society, with other economic and social dimensions of sustainable development? Next, please. So to get into this discussion, we need to look at the structures that shape politics, policy, science, and also the debate. And when it comes to forests and the climate, we often look to IPCC. In IPCC's global models, the main flow of carbon that is being considered is the harvest from the forest, which means that we have an emission from forest, which means that in, for example, the IPCC Global Land Report, forestry is stated to be 11% of the climate problem. Obviously, this is not a complete perspective. Then we have the LULUCF perspective, which is often used in the European context. There we account both for the harvest, but also for the growth and the sequestration of carbon in the forest. This is a better picture, it's more complete. We also have a very positive development in Europe since many years. But still, this model isolates the forest from the value chains and the benefits we get from the products. So therefore, we argue for a perspective that takes into account the full circular forest bioeconomy. And to do that, you need to illustrate what the value chain is doing. First of all, it stores carbon in the harvested wood products. We had that already in the LULUCF context. We recycle products. We also get substitution from products, which means that fossil emissions are stopped. We're using wood-based products instead. And finally, the carbon is recycled to the forest, where it grows again into trees and deliver further wood and so on. This is the circularity. This way we can look at the sector as a whole, and we can start analyzing what the total benefits are. Next, please. We also need to look at some details within this model. When we say harvested wood products, what we mean is an extended storage of the carbon from the forest. For some time, longer or shorter, the carbon stays in products. And we account for this in the LULUCF calculations. And in the Swedish case, we account for about 6 million tons of carbon dioxide per year positively. That means that the carbon storage is increasing in our products. But we also need to consider that this is composed of two flows, one inflow, which is about 35 million tons, and one outflow, which is about 29 million tons. And if we were to reduce or even eliminate the inflow, we need to be aware that the outflow will still be there. And this is a fairly significant factor in the calculations that we will see later. Next, please. We also need to think about what we mean when we say substitution. It's pretty obvious to everybody involved that when we use wood-based products, we don't use fossil alternatives. And that goes for solid wood material, it goes for packaging material, it goes for bioenergy. But the analysis of the substitution effect has varied in the literature and over time. And I think it's important to look at it in a way that correctly illustrates what would happen if we did not have the forest-based sector. So therefore, the correct question to ask is, if wood-based products were reduced or eliminated, how much fossil emissions or cement emissions would we have instead to replace those products? That way, we will get an illustration of the magnitude of the contributions that the forest-based sector makes. Next, please. If we then start looking at some of the effects of forestry and forest products, let's first look at the short term. What happens immediately when you harvest 1 cubic meters of wood in the Swedish case? Well, first of all, 1/3 of the tree is left in the forest, and 2/3 are taken out as wood. That's the first thing we need to consider. Of that, about 0.9 megatons of carbon dioxide equivalents that is taken out of the forest, just over half becomes bioenergy in the fairly short term, either directly because it is bark or wood that is not useful for anything else. And that, of course, becomes biogenic emissions. Slightly less than half becomes products, either fiber products or solid wood products. And they, of course, have a longer life, so we don't count on any immediate emissions from that. And both the bioenergy and the other products substitute fossil emissions. And the illustration here shows that with the current assumptions and the current research and the numbers we get from that research, that cubic meter will stop about 0.5 megatons of fossil emissions, which happens to be the same as we're emitting in biogenic emissions. So in the short term, nothing happens in the atmosphere. To that, I should also say that the factors that we estimate the substitution are conservatively set. We need to review this further, and we can probably look forward to increasing that number with further analysis, but that's not done in this study, and we should not rely on that. And then to take this to a dynamic model, we of course need to take into account the further decay of the wood in the forest, how quickly the products become carbon dioxide again, and how much the forest grows. And that's what we're going to get into now. Next, please. Very quickly, if you look at one stand in the forest, in the way that we manage forests in Sweden, that is, believe it or not, mainly through clear cutting. This is the established method. There's a separate argument about that particular method, but let's look at what happens when we practice forestry. If you started in year 0 in a typical mid-Sweden forest stand, and you harvest it, of course, you will reduce the amount of growing trees. The carbon in the growing trees will go down to 0, and then only slowly recover. But then we also need to account for the carbon that remains, as I mentioned, in harvested wood products and slowly decays. We need to account for the wood that remains in the forest, the biomass that remains in the forest, in stumps and roots, etc., and slowly decays. And we need to account for how much the fossil emissions, are being displaced. If we do all that, then we will still see in the short term, and actually in the first 57 years, that we will get a dip. We will get a net emission of carbon dioxide. And only after that can we account for a positive effect. So for the one stand and starting counting at harvest, yes, we have something that is a dip. We could call that a carbon dip. But the forest contains stands of all ages. And since the result is positive seen to the overall rotation period, we will constantly get a positive number here. Next, please. And to add to that, we also improve forest management over time. So the next generation of trees will grow faster. We will get more climate benefits. We also have innovation in the industry and effectiveness gains, which will also increase the climate benefits. So the question becomes, do we still have a short-term carbon debt? Next, please. So what we did then was to compare different scenarios. We looked at what actually happened in the past 40 years. We know that. We measure very thoroughly what happens in the forest, and what products we produce. Secondly, we looked at what would have happened if we had not harvested the forest. And of course, we will get all sorts of different developments. We will get damages to the forest, and we will, of course, not get the substitution effects. And then finally, we looked at what would have happened if we reduced the harvest by 10%, which is perhaps a more reasonable scenario. And when we did these comparisons, we got to some interesting results. First of all, it's important that we base this analysis on real-world data. These are measured actual developments in the forest over the past 40 years. We know that, you see the top line, that the carbon storage in the forest has gone up. We know that, that's the orange line, harvesting has slowly increased over the same period. There is a peak in 2005 when we had a major storm event. And we know that over time, the gray line, the accumulated harvest is of course very high. Over these 40 years, we harvested about 3 billion cubic meters. Next, please. So in a nutshell, Swedish forestry is about eating the cake and having it. This is a slightly longer time period. Since 1955, we've increased the growing stock in the forest by 57%. And at the same time, we harvested more than 4 billion cubic meters. Next, please. So what happens? Well, the interesting thing is what happens with the atmosphere. And if we look at the case, what actually happened, we know that we measured it, so we know what happened in the forest, etc. Then we can see that the carbon storage in the atmosphere went down by 1.84 gigatons of carbon dioxide. That's quite a lot. The annual global emissions are about 40. So Sweden alone over this time period reduced by 1.8. We know that this ended up in the biosphere. The biosphere storage increased by about 2 gigaton. And we know that the industry in its value chains used some fossil energy to produce their products. This is a relatively small amount, 0.16 gigatons. It's still large in absolute terms, but in relative terms, it is actually quite low, since most of the energy in the sector is taken from internal bioenergy. So let's see then what happens if we didn't harvest anything. Well, first of all, we would have also in this case an improvement in the atmosphere. We would take out about 0.87 gigatons of carbon dioxide. That's good, but it is not at all as good as the what actually happened scenario. There's a 1 gigaton difference. Of course, we would have a much higher accumulation of living biomass if we don't harvest anything, but we would also have considerable damages and losses in the forest from fires, from insects, etc. And we would also have some other effects on the product storage, which I will come back to. Most importantly, to replace all those products, we would have had major emissions from fossils. And that is, of course, what makes up the big difference here. We would have less climate benefits because we would have much more fossil emissions over this period. Next, please. This is exactly the same results, but shown in a slightly different way. This is the time scale, and to the left, you see the what actually happened scenario. The green area shows the accumulation of carbon in the biosphere. The black is the emission of fossils, and the balance is what happened in the atmosphere. To the right, you see this, the corresponding figure for the no harvest scenario. You can see that there is a higher accumulation of biomass over time, but not as much higher as you would expect, perhaps. And you see the much higher fossil emissions and the considerably smaller positive effect on the climate. The main reason to show this figure is to show that the difference is valid after 40 years, but it is also valid after 10 years. So also in the short term, the as actually managed scenario is better. Next, please. We're now moving into the last slide, and it's a little bit more complicated, but I want to explain a few things inside this. Top left is the same as actually happened scenario, but it's divided into a few more things. You can see that the orange part is the increase of harvested wood products. The yellow part is the stumps, roots, and branches remaining in the forest, which is moved into a dead biomass pool. And then you have the green, which is the living biomass. Top right is, as before, the no harvest scenario. And note that this is the no harvest scenario with 4% losses per year of the growth. We lose that to fire, to insects, to storm felling, etc. But there is one factor added here. You see a gray field that is an emission, part of the emissions. This is the outflow of harvested wood products. You remember, we stopped the inflow, but we still have the outflow. And you can see that this makes quite a big difference. Of course, this outflow will decrease since there will not be any new products added to the pool. But still, it is a big factor, particularly in the short term. Bottom right is the no harvest scenario if we assume a slightly higher loss due to damages. And when we made these assumptions, I, of course, tested this with the research colleagues, and they consider these assumptions conservative. It is very difficult to predict what will happen in a completely unmanaged forest if we switch to that situation. But we should consider these approximations as conservative. And you see that if we move to a 6% loss per year, the climate benefit will totally disappear. We will have zero effect on the climate after 40 years. Finally, bottom left, if we reduce harvest by 10%, wouldn't that be reasonable? Well, the results show that there would be no effect, well, literally no effect at all on the climate. This is because we would have less products, we would have less stumps and roots, we would have a slightly higher living biomass, but the balance of all this is that we would be at the same total level as in the actually managed scenario. We would also have higher fossil emissions, which is, of course, in itself a bad thing. So next, please. To conclude, and I think I mentioned most of these conclusions, so I will not repeat all of them, but the main conclusion is that active long-term forestry with efficient wood-based product value chains is a big part of the solution, both in the short term and in the long term, provided we take all factors into account when we make these calculations. Thank you very much.
Thank you, Peter. We have questions already pouring in, and we'll try and answer as many as possible after both presentations. But we have one which is more fact related, so I'll ask you directly. How much of the mentioned 0.4 tons of carbon dioxide is fiber and wood is fiber used for paper?
Well, the total output of the Swedish forest industry is about 19 million cubic meters of sawn wood and panels. That's the solid wood part. And about, if I remember correctly, 12 million tons of pulp that then becomes paper products. In terms of volume from the forest, it's about equal shares.
Okay, thank you. And thank you for the presentation. Now we will hand over to Professor Gert-Jana Boos. And I hope technology is with us.
Yeah.
Yes, I can see you.
Good.
Yeah.
Thank you very much.
Welcome. The digital floor is yours.
Okay, thank you very much. And thank you very much for giving me this opportunity to give a short reflection on the report by Peter Holmgren. And I think you can see the slides now. I'll try and do this in a few minutes. So Peter makes in his report basically 2 points or 3. Well, the IPCC model, he says, pays too much attention to the natural sink and not enough to the managed forests. And his main point is that this regularly managed forest is more beneficial to the atmosphere than a strict reserved forest, where you would have to use more, in that case, you would have to use more fossil fuels. And the example that he gave is for Sweden, and the graphs you see there on the right, where on the bottom graph, there is more buildup of biomass in the in the forest. But in this case, you would need to use more fossil fuels, which is the black, and then the blue being the net effect in a no harvest scenario. In a managed forest, you still have a buildup of growing stock. That is certainly right. There is still a sink, but the sink is smaller. And in this case, you're producing products and you substitute concrete and steel, etc. So your use of fossil fuels is far less here, giving this positive effect of reduction of atmospheric CO2 in the blue. That's his main point, and I'll try and go through these. First, something on the IPCC model. Yes, he is certainly right that the IPCC model has big shortcomings. I'll try and explain that. Even though this managed forest and managed agricultural land was also part of earlier IPCC assessments, but the IPCC model, what it means is very often in the global analysis, so-called integrated assessment models are used. And they have all the sectors incorporated, but they're very simple, or rather simple, on managed lands, and they're very simple on forests. Usually they have just a few types of forest globally, where it's usually the primary forest, and then there are small areas of managed forest lands. And here you see the map on the bottom right. In red is what the integrated assessment models see as managed forest. And basically these are where the land use changes are taking place with a little bit of regrowth in some areas. But well, I think most of this audience will see that if you consider only the red as managed lands, that that doesn't cover really where the managed forests are in the world. And this is a big discrepancy in the analysis as well, is where the integrated assessment models just calculate with the red areas, while the national greenhouse gas inventories calculate as managed land the yellow areas, much bigger areas, and also allocating and finding much more of the sink on the yellow lands. And this was a difference of 5 gigaton. And this is now gradually being corrected, you can say. And it's gradually getting into the IPCC that this managed land with all the products and the substitution, that is certainly part of the full picture and should be part of the full analysis. But you must recognize or see that earlier on, for many of the people doing these global analysis, simply the red areas was the managed land. Quite a big shortcoming. The second point that Peter makes is that, well, he acknowledges that in a managed forest there's still an increase in carbon stock, but the increase is smaller. So there's certainly no depth, but the increase is smaller, and that this difference would be compensated by saving the fossil fuels. And then you calculate with substitution factors, and Peter uses 0.5 ton CO2 per cubic meter of all the harvest. So he puts the substitution factor on all the harvest. And well, I think in literature reviews, people generally tend to work with a slightly higher substitution factor, but only for the final product, for a certain set of final products. And there, I think, so he's right that there is no carbon depth in case of most of the managed forests as we know it in the US and Europe and parts of Canada and Russia. But this reduction in the buildup of stock, is that really compensated by reduced fossil use? And this, I think this is where probably Peter is rather positive by using a substitution factor on the total harvest, where most people use it on the products themselves. And for that, we also have to look at that. If we look at the total European harvest, only 7 to 8% really ends up in long life construction. So there's a large volume is in short life products and do not necessarily always compensate so efficiently or substitute efficiently. For example, in Europe, more than 100 million cubic meter of wood harvest is actually private firewood, which generally burns at a low efficiency. So it's, I think here Peter is quite positive on the substitution factor. So I agree that Sweden has built up both stocks and was able to increase the harvest. That's a very good point. But there is also always a but. Sweden, not the whole world is like Sweden. And what you see here in the picture is the actuality in Central Europe with the bark beetle damages. And what we're certainly starting to see is when you have a sink in your managed forest, it's very difficult to maintain that sink. And I'll just show one example where we ran such a bark beetle affected country, the Czech Republic, with efficient model. A minus means a sink here, and this is what Czech has reported in the past as the sink. So the sink is declining a little bit. And then when we run what we call a climate smart forestry scenario, and you're changing that large area of bark beetle affected spruce into a more mixed and partly deciduous forest estate, you're actually taking it through a source period. And if you do the conversion faster, you're actually taking it to a bigger source. If you do the conversion slow, you're able to maintain the sink, at least at some level. Here we also took into account the half the wood product substitution effect, but only to the final products. And there it compensated something like 20% of this difference between the yellow and blue line. So this is also a reality that we have to see. We cannot always maintain these things in a managed forest. Finally, so yes, very right. Without the forest products, we would have much more fossil emissions. How much, I think, is a point of a debate. And certainly right, IPCC has not given enough attention to the managed forest and the value chain. Sweden, I mentioned already several times, yes, this was an example of how to both maintain stocks and increase harvest, and a case where in this managed forest, there is certainly no carbon debt occurring. But I also showed the different circumstances, for example, for Czech Republic. And I fully agree that this integrated chain gives a more nuanced picture than just looking at the dynamics in the forest biomass. And with that, I want to close, and I actually close with a picture of a Dutch forest, a Dutch forest reserve. These are strict reserves since the 1985, and this is a large stand that is starting to show these natural dynamics that also Peter referred to. But still, I do think at some places we also need reserves, and they're also beautiful.
Thank you, Gert-Jan. Very interesting. When I listen to you, I actually two question arises for Peter. The first one is that Gert-Jan says that, yes, this is true for Sweden. You can both eat the cake and have it, but it's not true for the rest of the world. Do you agree?
Largely, yes. I believe it's fair to say that we have in Sweden and Finland particularly a more active forest management. And hopefully we will not end up in the same levels of damages that you can encounter if the value chains are not as effective and integrated with the forest management. And this is true whether you actively manage the forest, as the example you showed, or if you don't manage the forest, which is the case in many other parts of Europe. So yes, there is a difference.
And my other question is that Gert-Jan says that it's too optimistic to sort of include all products. You should only include the long-lived products. Do you have any comments on that?
Yeah, I think that this is pretty much the core of the discussion we need to have, and which I would very happily also engage further with science to develop. How do we view this as substitution effect, and how do we look at the possibilities to become a fossil-free Sweden or Europe or whatever geography we're looking at? This is, of course, not separated from the political processes. And one thing to mention is that, as you've seen, bioenergy is a big part of the integrated value chains. But bioenergy in the European context is a different political process. And therefore, we have difficulties to look at the full picture in the analysis that come out. As Gert-Jan shows, that there are analyses that looks mainly at construction wood. Fair enough, but that's not the full picture. And then also, we need to look at not just the immediate use of the products, but also the recycled products and also the end use of products. So in my view, there is a bigger picture when it comes to substitution. And we should not shy away from looking into the details of this, because the fossil emissions that we are not making thanks to the forest products is very, very significant and necessary if we're going to solve the climate problem.
Do you have any comment to that, Gert-Jan?
No, I agree with Peter that on these substitution factors and the actual harvested wood products analysis, that there we can still improve a lot on the system analysis and looking for alternative management regime, but also certainly also alternative ways of using products, recycling products, and how best to substitute fossil fuels and fossil products. That, yeah, we really need more attention for that.
We have a question from the audience to you as well. Is it true to say that there is no climate trade-off between net emissions and high logging rates, even in a 10-year time frame?
Is that to Peter?
It's to you, sorry.
Looked like one for me.
But it was actually addressed to you.
Okay, can you say that again? Sorry.
Okay. The question is it true to say that there is no climate trade-off between net emissions and high logging rates, even in a 10-year time frame?
Yeah, well,
that's basically the essence of Peter's report.
Yeah, that's what Peter's report says. And I would say, well, it certainly depends, but maybe that's not an answer, but it depends how you manage what you do with the products, as Peter also outlined in his talk. You cannot just simply say that, you know, if it sort of always and fully compensates each other. And there would be a full trade-off between less or more harvesting or less or more fossil fuel use. It fully depends on the products, on the type of management.
Okay, thank you. Thank you so much for giving a perspective, or your perspective, of Peter's report, and I hope that this will be a continuous discussion. Happily, we have loads of questions from the audience, and we are going to see if we can answer as many as possible of those. And we are joined here by Emma Berglund, who is our forest director, who joined us in May. Emma, you've been listening to both Peter and Gert-Jan. What are your reflections?
Yes, thank you, Vivica. It's been really interesting to hear you, to hear your reflections, Gert-Jan. And I think it's true to say that forests are a solution both today and tomorrow. And for me, with the EU policy developments in mind, this feeds right into the discussions. We have the EU Forest Strategy, the LULUCF, the Renewable Energy Directive, the Biodiversity Strategy. All of these policies are being discussed, being developed, and they are all about the role of forests. And I fear that the discussions are taking a too narrow view of forests, missing actually to get the full benefits. So I think this report really feeds into the discussion, giving a broader perspective. We see that we need to consider the consequences for the entire society when we do these analyses. So the system perspective, I think, is really something for the policymakers to use and to look at this study to get a better view. So for me, it's a clear also political implication. We should support a growing circular bioeconomy to actually reduce the atmospheric carbon.
Thank you, Emma. And now we have questions from the audience.
Yeah, we have a question for Peter. No harvest scenarios are based at 4% and 6% loss of growth. These assumptions will, of course, control the outcome of the study. How would it appear if the calculations instead would be based at simulations, for example, this is a Swedish Eureka analysis tool with the current forest.
No, of course, it's true that this is sensitive to the assumptions, and those assumptions are detailed in the report. And it would be good to investigate this further. As when it comes to the models in, for example, Eureka, they are quite good as long as the forest is managed. But if we were to completely abandon the forest, I don't think we can use these models with a very high precision or accuracy. So it is an open question, but I think experiences from other regions, other geographies where you don't manage the forest as intensively, you will have lots of damages instead, and you will have lower overall growth. So this is definitely a factor. Whether these assumptions are the correct ones, or if they are too low, or if they are too high, let's continue to research that.
And we have another question. In addition to climate effects, did you also study biodiversity effects in these scenarios?
It wasn't part of the study, but of course, what I did mention was that the analysis that we make for the climate must take into account externalities to what we're studying. And that goes for the economic benefits, the social benefits, and of course also the biodiversity situation. There's no doubt, and there is no controversy over the fact that we need to take care of the biodiversity. And I should also mention that the as actually managed scenario builds on the existing Swedish forest politics and Swedish forest law, which takes biodiversity into account. And the logging levels, the harvesting levels that we've been looking at is actually something like 75% of the overall growth. The rest is left in the forest to increase the carbon stock or happens within protected areas. So it is not as this is a full harvest scenario. It is what actually happened. And what actually happened was that we took care of biodiversity also.
Great, thank you. We have another question for you, Peter. Why are you criticizing the peer-reviewed science on carbon payback 1 month before the Euro Commission publishes its proposal to revise the Renewable Energy Directive?
That's a strange question. Well, first of all, I've been criticizing it for much longer than that, so that's not a new issue on the table. As you mentioned yourself, Emma, I think we are in a very interesting period of policy developments in the European Union, and of course, we should have as many facts on the table as possible.
Okay, thank you. And we have another question. As I understand it, you are in agreement, both you and Gert-Jan, that Nordic forestry is climate positive. How is it best communicated to the Commission and other EU institutions where the perspectives today often are very different?
Well, that is the million carbon dioxide ton question. We're trying to do it right now. I think we need to have a much more open-ended debate. And I think the holistic perspective of the forest-based sector is key when we discuss the issues that we're talking about. The co-benefits between the economic performance and the climate benefits from forest management and the forest industry needs to be made much more visible. At the moment, we see a lot of debate happening within silos, the climate silo or the biodiversity silo or some other silo. This is not valid when it comes to the forest-based sector.
Thank you.
And when we talk about these silos in the climate discussions, there is a lot about the focus on the sink. So from a forest management and the forest ecosystem perspective, there is a question here. Is it possible to maintain or even increase the forest sink over time? And how can this be done?
Yeah, and a big part of the study is to show that it's not enough to look at the forest in isolation. We need to include the circularity and the interactions between the value chain and the forest in both directions. I think we have shown that it is possible to increase the forest net sink over time. Actually, it's not increase the forest net sink, it's increase the forest carbon storage through a net sink. We've proven that that's perfectly doable in Sweden, and it's still going on. For how long can we continue? Well, it depends on how well we manage the forest. I think Gert-Jan has done much more studies on what happens in the European context with the forest net sink. And it is fair to say that some of the assumptions that we see in the EU policy developments are overambitious when it comes to storing carbon or parking carbon in the forest as part of the solution. I think we need to recognize that managing the forest is key for a stable and increasing carbon storage.
Thank you. We are often met by the argument that we should consume less. So the substitution effect will be reduced if we do so. Why have you not counted this into the calculation?
There's no doubt that we need to look at our consumption patterns. That's clear. There's also no doubt that we need to look at all sectors when it comes to reducing emissions and innovation and more efficient value chains. That's true in the forest-based sector, it's true in the steel sector, it's true in transportation, it's true everywhere. So if you want to study this, you have to put some things, you have to put down a system boundary. In this case, we chose not to look at reduced consumption as a result of reduced harvesting, because that would be isolating the forest-based sector from all those other sectors. Sure, we can look at what happens with the climate effects with reduced consumption as part of the equation, but then we need to look at all sectors together. And also, if we were to reduce any part of consumption in society, wouldn't it be smarter to reduce the fossil-based consumption first?
I definitely think so.
Okay, but if we look at these scenarios, if you would calculate with more recycling and to use more long-lived products, which is something we hear that we should do, how would this affect the study?
Well, again, I agree. We hear a lot about the long-lived products as a means to reduce our climate impact. And I agree, of course, it's good to have products that last longer, not just wood, but in any material. So that's definitely a way to go. We should build more houses in wood, etc., etc. But what shouldn't be done is to confuse the effect of storing carbon for a longer time in a house with the substitution effect of not building that house in steel and cement. Those are two completely different factors. And in fact, you can have a very short-lived product with a very high substitution effect. And that would be good in its own right, even if it's not long-lived. So we shouldn't fall in the trap and say that long-lived products are always better, or that long-lived products is the solution we need, because that's not the full picture.
Now we have a question regarding the energy sector. And the question is the comparison with fossil really the right one? Shouldn't forest-based bioenergy be compared to other renewables rather than fossils? This is actually a question that I would like both of you to answer, but perhaps Gert-Jan, if you heard the question, would you be willing to answer?
Yeah, I heard it. Should we compare bioenergy not with other types of energy provision? Yeah, well, that's part of the picture. I do believe that, well, when you look at the total energy mix as it's projected for the coming decades, you see that our energy provision will certainly be a mix of all kinds of sources, where solar and wind will certainly be a big part. Biomass, bioenergy has other advantages of being able to compensate for fluctuations in solar and wind. It could provide also for transport fuels, so it has other advantages as well to maintain such a mix of energy provision sources.
Right.
Do you have any comment on that, Peter?
Yeah, no, it's an important topic, and what we need to have clear is how we formulate the question. And if the question is, if we stop forest bioenergy today, what would we need to do? Well, in the Swedish case, we would start burning fossils in our combined heat and power mills. That's what would happen. And for the foreseeable future, we have enough fossil emissions to get rid of. So that I don't think there's any big competition between which renewable is doing the job. We all need to contribute. And so I should also say that in Sweden, we have more than 1/3 of our energy provision from bioenergy, and most of that from the forest in some form. And we have that now. If we go back to 1980, when the study period started for this particular report, at that time, we had lots of fossil emissions from our energy sector that we have now got rid of thanks to bioenergy. So this is a clear and actual substitution effect that we've had over a long time in Sweden.
Thank you. Another question on the biodiversity. Science tells us that the endemic, near natural biodiversity and biomass-rich forests are more resilient to the climate crisis, which is already today harming our forests. So how does this cope with continuing to harvest at large scales?
I'm always suspicious when a question asked starts with "science tells us," because that already means that you have selected what you want to say. True, there are many situations where an unmanaged forest would be better for biodiversity, perhaps for resilience and adaptation to climate change too, but it's not the full picture. We manage forests. We've done that for a long time. We want to continue doing it. And the best way we have for climate change adaptation, that is to avoid risks in the future, risks of social character, of economic character, of environmental character, is to adjust how we manage the forest. There are many ways we can do that, and we need to develop them. But I think it's way too simplified to say that if we leave the forest alone, that's the best thing we can do.
Could I?
Gerda, would you like to add something?
Yeah, I certainly agree that it's not either or. It's not or management or non-management. We certainly have the space in European forests to do and in some locations you have a bit more intensive forestry. In other locations you have less intensive. You can spatially segregate that partially, and even in some cases with integrated forest management, you can also integrate some of the values at the same stand. But like the photo I showed of a strict reserve in the Netherlands, if you have strict reserve on a few % of your forest, that's perfect. It doesn't harm the industry, and it can certainly go along with each other very well, spatially aggregated.
I really take that to heart. And. I like that. Does the study take into account the increased risk of forest fires due to a warmer climate over time? Or do you assume that the forest industry will abate the risk through an increase of mix of the types of trees and different ages of trees?
Yeah, that's actually two questions. On the first part, I would say yes, because the risk of damages that is increasing with less managed forest is included in the study. But I think the second part of the question is the actual question here, and that is how will we handle the increased risks with changing climate? That's what I just mentioned. We need to adapt our management methods. Whether or to what extent that means that we go into some popular methods in the debate that excludes clear cutting. It's difficult to say, because not clear cutting comes with other risks, and it comes with other consequences. So I think again we have a simplified debate where it is believed that managing the forest less intensively would be better. I'm not so sure. It's not generally true, and in fact, in many cases, we will need to manage the forest more intensively to be able to adapt to the climate changes.
Thank you. Now we have a question about your graphs. The fossil fuels are considered in the negative part of the graph. This is quite counterintuitive, as we are used to consider the CO2 atmospheric pool as a reference. So fossil fuel comes as addition to the pool, not subtraction. Can you comment on that?
Well, the graphs are on the positive side, the increasing carbon pools, and on the negative side, the decreasing carbon pools. And in fact, what we are doing in all these scenarios is that we are decreasing the amount of carbon in the atmosphere, and we are decreasing the amount of carbon in the lithosphere, that is the fossils. And we are increasing the carbon in the biosphere. That's true for all the scenarios. So I don't know if that's counterintuitive, but it's the pluses and the minuses together.
Okay, thank you. Our hour is running up, but before we conclude, I would just like to ask Gert-Jan, do you have anything that you would like to add before we conclude this session?
No, I'm okay. I'm fine.
Good, thank you. Then I would like to say thank you to Peter for this very good summary of your report, and thank you, Gert-Jan, for sharing your views on the report. And I would also like to thank the audience. When you have these digital events, the greatest fear is always that you will be talking into nothingness, but you have been a very active audience, and we have lots of questions. Unfortunately, we haven't been able to answer all of them, but we see this as the start of an ongoing discussion, and we will try to address all the questions that have been posted here on Menti today, and we most of all would like to talk to you, and we would like to continue the discussion, and we hope to do that after this summer. But if I were just to conclude, Peter's report shows that in Sweden you can have the cake and eat it, provided that you take into account the substitution effect. I mean, you need, in order to build welfare, we need to have consumption, even though there's, of course, we should exclude unnecessary consumption, and that consumption should be based on fossil-free products. So the climate benefits are clear. They're also, it's also been clear, not least from what Gert-Jan has explained, that it's not one size fits all. We need to have different solutions in different countries, and that needs to be taken into account in the legislative work, both in Brussels and in Sweden and in other countries. So there's still work to be done, and I think that this report is a good starting point on which we perhaps can, or hopefully can, build fact-based discussions so that we can find a solution that benefits us all. So that's all from us. But before you leave the meeting, please stay tuned, and because we would like to present a short film about the resource efficiency of wood. Now I can't even speak any longer. Thank you all.